Welcome to the place of rest, where our aim is to give you language that helps you displace the growing confusion, chaos, and dis-ease of our times. In today's episode, Virginia and Dr. Cowden reveal mitochondria as the key to cellular vitality, weaving together science, nutrition, and a holistic view of healing. We hope you enjoy today's conversation.
Dr. Cowden, as we were just mentioning briefly, I'm just humbled by really God's grace and connecting our paths on this side of eternity, because you've been instrumental in helping me understand why Jesus of Nazareth, claiming to be the Son of God and declaring that he can substantiate the merit of those claims by really quoting thousands of years of recorded history that was before him, came before him, right? And really fulfilling so much of that history. But his invitation to humanity was to rest, because rest is the only way to reconcile the communication among our own constituents, spirit, soul, and body. But then after he invited us to rest, right, he said, come learn from me. And you're such an instrumental part of that journey for me, because you'd really take it down to the nucleus of our very constitution and our very structure. And I understand such a small percentage of everything you shared in the last podcast, specifically about the workings of the mitochondria. So I trust that the immensity of the laws of nature that you so well played out for us and explained, the inner workings of the extraordinary components of our innermost parts, it's really gripping. It's enough to ask, how could there be no God? Yeah.
Amen.
Right? So the second part of this is going to be tough. It's dense. I want to encourage those listening that perhaps it's not exactly for you in its entirety, but doctors, nurses, people that understand the basic tenets of the anatomy, that can really absorb this information in a whole different capacity. And I love what you said, Dr. Cowden. Virginia, take what you can and take what belongs to you right now. And it's always in philosophy and theology for me. I think the inner workings always comes back to God and design for me, right? And apologetics, really, making a defense for the existence of God, the role of the Holy Spirit, and honestly, the reality of Jesus and who he said who he was in the context of our healing. That's probably my sweet spot. Thank you for breaking everything down. And I just wanted to encourage our listening audience, be patient with the process. Take what you can, just the seed of an idea, IV drip. It's sufficient. And then subscribe to the channel if you can, but then share these podcasts strategically with the people that God leads you to.
Yeah. Share with those that may have a more in-depth background in physiology, biochemistry, medicine, whatever. And take what you can out of it. But I think the biggest take-home message from all of this is wonderfully and intricately we are made from the creator of the universe. And if you don't get that from this, then I don't know what you can get it from. The intricacy of the biochemistry of the human body is mind-boggling.
Mind-boggling. And Dr. Cowden, I know people don't have full context for who you are and your whole story. And one day I'd love to do a podcast just on your whole story and the fingerprints of God at work in your life, ruling and overruling, directing you. You made your plans, but God directed your path. So people can have full context really for your genius and your gifting. But until then, we're ready for this next segment of this next presentation.
So last time the presentation talked about mitochondria. Mitochondria are the little organelles inside of our cells that produce the vast majority of the energy for our cells. So without mitochondria, we die. So they're pretty important. And I focused quite a bit on the mitochondria in patients with amyotrophic lateral sclerosis, because usually those patients have a poorer function of their mitochondria than any other patient. And if you can figure out how to improve the function of the mitochondria in an ALS patient, a patient with Lou Gehrig's disease, then usually you can figure out how to improve the mitochondrial function in any patient. Patients with Alzheimer's, dementia, Parkinson's, multiple sclerosis, autism, cancer, arthritis, autoimmune disease, blah, blah, blah. So we're going to do a couple of slides of refresher memory from the previous presentation so that you aren't completely lost as we dive into the rest. This is an image of the cell membrane of our cells, microscopic. Those little red balls are phospholipids with the yellow tails hanging down. And that's a phospholipid bilayer that excludes from the cell things that shouldn't go into the cell and helps to get in through those proteins and through those pores, things that should get in. And I'll remind you that on the far left end of this is a channel that's probably for a protein, but it could be also for calcium. Dr. Martin Pall, Pall, figured out back in 2012, I think it was, that the voltage-gated calcium channels on our cells, of all the cells of our body, are stimulated by electromagnetic frequencies, by electropollution. And so that little green Y coming off the top of that protein could be one of those little antennas that picks up that ambient electromagnetic pollution and tells the pore to open up and allow calcium to flood into the cell. If that happens, then you get a free radical damage inside the cell. You form peroxynitrite and superoxide, and it stimulates the cell to release glutamate into the surroundings. The glutamate that's released causes a damage to the neurons in the brain, and some of those neurons die as a result of that glutamate release. Some of the neurons die because of the free radicals that are being released into the cell from the calcium flooding into the cell. Anyway, this phospholipid bilayer is really important, and electropollution is very important because of the voltage-gated calcium channels that cause the free radical damage inside of our cells. As I mentioned last time, the fats and the phospholipids are really important in order to maintain the electrical charge across the cell membrane. We have about minus 70 millivolts of charge across our cell membranes when we're young, when we're first born. By the time we get to be 50, it's down to about half of that. When we get to 70, it's down to about half of that. So at some point, our charge across the cell membrane gets so low that our cells start dying. And when they do, then we die. So it's really important to maintain the cellular charge, and you have to have proper phospholipids in the cell membrane and proper fats in the cell membrane to accomplish that. By the way, those little yellow things in the cell membrane are molecules of cholesterol. And, the pharmaceutical industry has made cholesterol into a villain, and you got to take drugs to get every bit of the cholesterol out of your body. But if you do, you die, because cholesterol is used to stabilize the cell membranes. It's used to make bile salts. It's used to make steroidal hormones. It's used to make vitamin D. It's used to make a lot of other things that are essential for our body. So cholesterol is not a villain. Okay, I showed you this last time also. This shows you how glucose can come through the cell membrane there at the top into the interior of the cell and go through a bunch of enzymatic steps to make pyruvate. And then pyruvate then goes into the mitochondria, into the TCA, tricarboxylic acid cycle, to make NADH. The NADH goes into the electron transport chain, shown there with the 4 bars with the little E minuses above them. And that's where electrons are transferred along that chain to the final electron receptor, which is ATP synthase. Adenosine triphosphate synthase is an enzyme that combines ADP and inorganic phosphorus to make 32 molecules of ATP, and that then powers our entire cell and all the cells of our body. The only cells that don't have the mitochondria are the red blood cells, so they have to produce what little ATP they get from the glycolytic pathway there in the cytoplasm between the cell membrane and the mitochondria. This is just one mitochondria of several hundred that are in each cell. So don't think that each cell just has one mitochondria. They have hundreds. Heart cells have between 5,000 and 8,000 mitochondria per cell. The heart muscle is highly metabolic and requires a lot of energy. This is another one I showed from last time. So this shows the different types of macronutrients coming in at the top, the fats, the carbohydrates, the proteins, and how they're all basically catabolized into acetyl-CoA, which is in the center near the top. Now, the acetyl-CoA goes into the mitochondria and can go into the tricarboxylic acid cycle, also called the citric acid cycle, and forms a lot of NADH and a lot of and some FAD. If you produce enough of the NADH and FADH, those molecules go down there into the image on the bottom line, which shows the four electron transport chain complexes. They're enzyme complexes that shuttle electrons along from one molecule to the next until it finally gets over there to the far right one, which is the ATP synthase, which makes our ATP. And in the process of doing that, a lot of free radicals are produced in the mitochondria. And so you have to have glutathione to scavenge a lot of that. Mitochondria, as I said last time, also produces melatonin, which is a strong antioxidant, and it helps to scavenge a lot of those free radicals that are produced in the mitochondria. If you don't have enough glutathione, you don't have enough melatonin, your mitochondria get damaged so severely that they die, and eventually you don't have enough mitochondria to produce the energy that your body needs. So if you don't have the right nutrients, then this whole system doesn't work. You see up there between pyruvate and acetyl-CoA that you have to have vitamin B1, B2, B3, B5, and lipoic acid. And right above that, magnesium. So a lot of nutrients that we should be getting in our diets are not in our diets the sufficient amounts to provide the needs that we have. So that's why you need to take oftentimes a supplemental nutrient that has those other constituents in it that make these enzymes work. I'll say this, I just flashed up on the screen the AKG bypass in the bottom right corner. Now, that alpha-ketoglutarate can be given to a patient supplementally. It's really helpful for patients with ALS. It's pretty helpful for patients with Alzheimer's, dementia, and Parkinson's, and multiple sclerosis, and so on as well. But that's what we call the AKG bypass, because you can make some NADH and some FADH from that alpha-ketoglutarate to go into the electron transport chain to make ATP for your cells. But what happens to a lot of people is they're not getting enough acetyl-CoA into their citric acid cycle, or TCA, to be able to turn the circle there with all those enzymes, and so they become deficient in NADH and FADH and therefore deficient in ATP. So when you do the alpha-ketoglutarate, you start producing more of the NADH and FADH and more ATP. Now, the alpha-ketoglutarate is very acidic, so when you take that, you have to take it with something that's alkaline. Dr. Cowden, who developed this concept, combined it with arginine. Arginine is a very alkaline amino acid. It's also a building block for nitric oxide, so that helps to dilate the blood vessels, and that's another benefit from using the arginine alpha-ketoglutarate combination. When you put too much alpha-ketoglutarate into the cell, it produces too much glutamate, and that could be a problem. So the Diana protocol that Dr. Cowden created also has a gamma aminobutyric acid, GABA, a calming neurotransmitter. Glutamate is an excitatory neurotransmitter, and so those help to counterbalance each other. Okay, so I showed you a couple of pictures of portions of the Genova Diagnostics NutriEval test last time, and this is some more of those. You see in the bottom left corner energy metabolism components. Most of those were on that previous slide that I just showed you: citric acid, cisaconate, isocitrate, alpha-ketoglutarate, succinate, malate. Those are all there. Now you see some of these are too high. The citrate's too high, so you definitely would not want to take magnesium citrate because they already have too much citrate in their body. You would want to take maybe some magnesium alpha-ketoglutarate or some magnesium succinate to boost those up a little further. because those are also available in the marketplace.
I think what's important is www.gdx, for those of you listening, .net. Dr. Cowden has put resources here for you to be able to reason through this, study this material, and have a doctor or your practitioner order these tests. And he's giving you a blueprint so you can become an agent of your own healing.
Yeah, a lot of allopathic doctors are not familiar with this test and don't know to order the test. But if you can convince them to order the test, then that doctor can get on the line with one of the experts at Genova Diagnostics and learn how to read the test and then learn how to interpret it to you. So that would be a good plan. Now, this is another page from that testing process, and you see on this one
vitamin markers for those of you listening.
Exactly. At the top of that previous, slide before last, it showed that you have to have B1, B2, B3, B5, and lipoic acid. That's what that top section looks at to see if you have sufficient amounts of those. You don't want it to be these markers to be in the red zone for sure, but probably not even in the yellow zone. So out of all those, only 2 of those are in the acceptable zone, the green zone. Okay? Yeah. So you don't have to be, PhD in biochemistry to see that some of your B vitamins are out of balance.
Yeah.
And same thing for
what's the turnaround time on these tests, practically speaking?
Probably about a week, not too long. Yeah. But anyway, if you have a serum homocysteine, and by the way, every patient should request that their doctor order a serum homocysteine as part of their annual physical exam. If your homocysteine is elevated, then that means you probably have a deficiency of vitamin B6, folic acid, which is B9, or vitamin B12. And so if you're deficient in one of those B vitamins, then the homocysteine is too high, and homocysteine causes atherosclerotic disease, more so than cholesterol. Okay? But in addition, if the homocysteine is high, that means your S-adenosylmethionine is too low. I'll show you that on a subsequent slide here. So if you're, here we go. Now, this is a very busy slide, but what I want you to pay attention to is the top right corner where it says SAMe. That's S-adenosylmethionine. That is the primary methylator for the entire body. If you don't have enough methyl groups in your body, then you will have some of the neurotransmitters not working, and you won't be able to methylate viruses to make them inactive, and you won't be able to methylate your DNA and RNA the way you should to make them active.
And where is that first indicator, the baseline you just mentioned, the starting point right here?
Yeah, top right corner.
Top right.
Yeah, okay, top right corner, SAMe.
Yeah.
Okay, so that's the most important molecule, one of the most important molecules on this entire graphic. Okay. You got to have enough SAMe for everything else to work. If you don't have enough SAMe, your viruses are overactive, your neurotransmitters are underactive, and a lot of the DNA and RNA that needs to be methylated won't get methylated and do what they're supposed to do. Okay, so, but if your homocysteine, see down right below that, is high, that means that circle's not turning, and you're not getting anything up to the SAMe.
Yeah, right there. And where do you get a test that explains this?
Any laboratory in the United States can do the serum homocysteine, and should every year. Okay, now, another really important one in the top right corner is a creatine. 70% of the SAMe that's produced each day is used to make creatine so that you can make creatinine and get toxins out of your body through the kidneys. But if you take creatine as a supplement, then you spare some of your SAMe to do those other more important jobs. To methylate viruses, to make them inactive, to methylate neurotransmitters, to make them active, to methylate DNA and RNA, to make them active. Now, you see also down below homocysteine is the glutathione. Some people have a defect in that CBS enzyme, which is in the blue rectangle right below homocysteine. And if they have a genetic defect there, then they won't be moving things down that chain all the way to sulfate, and they won't be able to make enough glutathione for health. But if they take the molybdenum, which is right by the SUOX down there below that, then they'll be able to oftentimes improve that pathway enough to where things work okay. Yeah. Now, each one of these metabolic cycles is tied to the other. The methionine cycle tied to the folate cycle, tied to the tetrahydrobiopterin, BH4 cycle, tied to the nitric oxide urea cycle. So arginine, as I said, is what's in that Deanna protocol, and the arginine then can get converted into nitric oxide. Nitric oxide can dilate the blood vessels and bring more blood supply into organs that are not getting enough blood supply, and so that's a good thing. But nitric oxide is also a free radical. If you get too much of it, then you get peroxynitride and superoxide formed, which are damaging to the neurons, bottom left corner, neuronal damage. Now, so you want to take some creatine every day so you don't have to make so much creatine in your own cycle. And some people have to take glutathione, liposomal glutathione, because they're not making enough glutathione on their own. Or in the old days, we could take N-acetylcysteine. NAC is the most important building block for glutathione. But nowadays, because there's so much Roundup in the air and in the water and in the food, the Roundup competes with glycine in the glutathione and prevents it from binding there. And so you can't form glutathione now because you have so much Roundup in your body. So you have to take glycine supplementally to push that Roundup off of the enzyme that's trying to produce the glutathione. Okay, inside the mitochondria are melatonin, peroxyreductins, and magnesium superoxide dismutase. Those are three substances that help to neutralize the free radicals down there that are causing neuronal damage in the bottom left corner.
Does this show up in inflammation?
Whenever you have a lot of free radicals, you'll have a gradually increasing inflammation. Now, in order to get enough manganese inside the mitochondria to make manganese superoxide dismutase, you have to have about 2 to 5 milligrams of manganese per day. Now, there's only a few people that can't tolerate that, and usually you'll know within a few doses whether you're one of those people. Some people are, not processing manganese well. Anyway. Just remember, though, that nitric oxide, even though it helps to dilate your blood vessels and get more oxygen and nutrients into the tissues, it's also a free radical. And you definitely don't want it to be building up inside your neurons. Okay, so this is a little bit more about the Deanna protocol. You can get arginine from diet, from supplemental nutrients, or from protein turnover to make all these things on the right there. The protein, the urea, the creatine, polyamines, the nitric oxide, the proline, the glutamate, the agmatine, and that's the chemical structure of the arginine there on the top right. You see it's got a lot of nitrogens in it. And because of that, it's a very alkaline amino acid, a pH of 10.5 to 12.0. And that is very good because it helps to counterbalance the very acidic alpha-ketoglutarate that's in the Deanna protocol. And the GABA is added in order to balance out the glutamate that's produced from the alpha-ketoglutarate so you don't get too much neuroexcitability and too much neuronal death from excessive glutamate. Okay, since arginine is sometimes causing viral overgrowth, it's not a bad idea to take some L-lysine at a different time of the day than the arginine so that you can suppress the growth of viruses. Most of the viruses are immune suppressive and metabolically suppressive. So if you take some L-lysine, you would take exactly the same number of milligrams of L-lysine a couple times a day as you take number of milligrams of arginine to counterbalance that. So if you take your arginine at breakfast and supper, you take your lysine at lunch and bedtime and prevent the viruses from overgrowing, especially the human endogenous retroviruses. Okay, now, when you produce more ATP, you improve your transmembrane electrical potential. That's what's called the vitality of the cell. The lower the electrical potential, the lower the vitality of the cell, the closer it is to death. And so that's why the alpha-ketoglutarate is important, because if you provide that in somebody that has impaired metabolism in their mitochondria, sometimes you can produce enough ATP to keep the cell from dying. That's the goal. When misfolded proteins leak out into the fluid around the nerve cells, that's called amyloid protein. That causes damage to the other cells around there, and that's what's found in patients with Alzheimer's dementia is excessive amounts of amyloid protein in the space between their neurons, and also more tau protein. But when you take the alpha-ketoglutarate, you can reduce the release of amyloid protein and tau protein into the space around cells, and that further reduces the damage to brain cells. In order for the whole process to work, you have to have 700 times more NAD plus in your cells than NADH in your cells. So it's common for people to become NAD plus deficient. You fix that either by taking some liposomal NAD plus or by doing an oxidative therapy. When a person is hypoxic, then their electron transport chain stops because the final electron acceptor is missing and you're not converting NADH back into NAD, so you can't make any more ATP.
I'm listening to all this, Dr. Cowden, and I'm imagining myself driving in a car and they got an alert, the podcast, and it's like, wow, this is...
Yeah, listen to it once audio, and then next time you try to review it with the slides, because the picture's worth 1,000 words, and sometimes people are predominantly visual learners, and if they listen to it, they only get a little bit of it, but if they see it, they get a whole lot more of it. One of the most common reasons why people nowadays have hypoxia is because of accumulation of spike amyloid in the capillaries of their entire body because of shedding from other people who've taken the vaccine or taking the vaccine yourself. And then if that's happening, what you need to do is you need to take lumbrokinase or bromelain or nattokinase 30 minutes before food with water only, 2 or 3 times a day, to break that amyloid clot up and get it off of the capillaries so that oxygen can be delivered from your red blood cells into the tissues. Now, this is an important thing to know, is that you can assess the function of your mitochondria. You don't have to guess whether they're working or not. You can actually do a test and figure that out. It's called a mitome test. So you send a cheek swab to the lab, and a few days later, you get a 11 to 30-page report back telling you what's messed up with your mitochondria. And that's a very useful tool. It tells you which foods you should consume, which supplements, what your environmental toxin exposures have been, what medications you should and should not take, lifestyle strategies that affect your mitochondria, etc. Chris Masterjohn, PhD, is the one that developed that test. They're kind of proud of the test. It's about $700, but it's, again, you don't have to do it repeatedly. You do it once to find out where you are, and then take some of the suggestions that they make from the report and make those changes in your regimen, and then see what symptoms improve. It's based on 35,000 different studies, and there's 1,500 different distinct ways that your cell energy production can be optimized. So it's, there's 12 specific mitochondrial patterns. It tells you a lot of things that are on this next slide. Should you be...
Well, that's fantastic. That's fantastic, I just want to say.
Yeah. Should you be eating high carb or high fat? A lot of people philosophically have just chosen to become a vegan, and that's probably the worst thing they could do. They'd probably be better off as a ketogenic diet or even a carnivore diet. And if you persist on doing a vegan diet when you shouldn't be a vegan, you're going to pay the consequences at some point. What's your iron status? And is that limiting your mitochondrial function? Is high-intensity interval training beneficial for you? Are you a candidate for methylene blue? What supplements are going to help you or hurt you? What is the most powerful optimizers for your mitochondrial function? Is CoQ10 the best thing for you to take, or you should be taking MitoQ from New Zealand? And dozens more examples like this. This test is not available except in the 48 contiguous United States, not in Alaska or Hawaii, but at some point, maybe it'll become available there as well.
So on the last slide, you basically said what the test is. Then on this side, you're telling everyone what it can tell you.
Yeah.
And the slide previous to these two, you showed an example, right, of an output and how comprehensive they are. And I'm just saying that for the benefit of those that are driving, listening, because this is really a good anchor, I think, for us all to camp on, especially those of us that are still trying to absorb a lot of these basics.
Yeah. Well, I'm trying to get to the nitty gritty, the nuts and bolts. What can you do to make a difference? And that's what these two slides are about. So I mentioned MitoQ here on this previous slide. So what is MitoQ? So MitoQ is a man-made triphenylphosphonium cation that's combined to ubiquinol. Ubiquinol is the reduced form of coenzyme Q10 that is made by the human body. Dr. Carl Folkers, who did most of the research on that back in the 1960s, found that by the time you're 50 in the United States, you have a 50% chance of being deficient in coenzyme Q10 production in your own body and have to take it supplementally. If you're 70 years old, you have a 70% chance. If you're 90 years old, you're a 90% chance. If you're 100 years old, you're deficient. So you need to be taking ubiquinol, probably, if you're over 50. Now, as you age, you produce less and less ubiquinol, and it's absolutely essential for the electron transport chain in your mitochondria to work. It's not the only thing that's necessary. It's just one of many things that's necessary for your mitochondria to work. Okay, it's rapidly absorbed, taken into the mitochondria inside of our cells, and it's a powerful antioxidant and helps to protect the mitochondria. Okay, as the mitochondria are producing ATP, I mentioned before that free radicals are being formed, and those free radicals are damaging the mitochondria, and those that get out of the mitochondria are damaging the rest of the cell. So you want to definitely have enough antioxidants on board to quench the free radicals that are being formed in your day-to-day production of ATP. And MitoQ is excellent as far as protecting the mitochondria. Now, the free radicals also stimulate NF-kappa B. That's an inflammatory molecule in the body. And so that's the other reason why you want to quench the free radicals, so you don't get a lot of inflammation throughout the body. Now, on the previous podcast, I talked about the fact that we lose about 1% of our mitochondria in our cells each year of life after age 18. So by the time you reach 68 years of age, you've lost half of your mitochondria, statistically speaking. Some people a lot more than that. A few people that have been working hard at it, at not losing them, less than that. I've been taking supplemental nutrients since I was 20 years old. That's 50 some odd years. And I'm pretty sure my mitochondria are still working pretty well and have a higher percentage of mitochondria in my cells than the average person my age. But some people haven't taken good care of their body and probably have a lower percentage than you would expect based on their age. But anyway, the fewer the mitochondria you have, the less function your cells have, and the sooner the cells die and sooner you die.
Is this collapse a large contributor to autoimmune diseases, for example?
Well,
or does it explain a precursor to cancer? How can somebody make sense of this in a very practical way, how these deficiencies can show up in their life? Is that too broad of a question?
No, I can try to do some justice to it in a short period of time. But when you form free radicals inside your cell, which we all do, and you have excessive number of free radicals in your cell, some of the free radicals are going to get into the cytoplasm and are going to get into the nucleus of the cell and are going to damage your DNA and cause the DNA to become defective. One of the causes of cancer is defective DNA. Now, one other thing that happens as we go through life is we accumulate toxins. Okay, so in Germany, they have a field of medicine called homotoxicology. And in the study of that field of medicine, you find that a person goes from health into allergies once they accumulate a few toxins. Once they accumulate more toxins, they go from allergy on into autoimmunity. And once they accumulate even more toxins, they go on into cancer or ALS or some other severe chronic neurodegenerative disease. And in order to get well, you have to start getting the toxins back out of the body. As you remove the toxins from the body in somebody that has cancer or ALS, you go from that condition back to autoimmunity. And then you continue to remove the toxins, then you go from there back to allergy reactions. If you keep removing the toxins, you finally go back into health. So that's what's called reverse vicariation.
Dr. Cowden, and I'm sorry to interrupt you because I know this is such an important flow, but just for accessibility for me personally and some of our regular listeners that follow us, when we do TKM, for example, we have noticed that the results are immediate. And we notice that several people have gotten really sick and have had to go to the hospital or have had an allergic reaction right away. But we are excited because we see that as the step towards healing, but it's kind of scary going backwards too.
If they're going to the hospital, that's a dangerous thing for them. One of the smartest men to ever live was Dr. Linus Pauling. And Dr. Pauling won 2 Nobel Prizes. I don't know anybody else that has. And he said, don't go to hospitals or allopathic doctor's offices because they're dangerous places.
Yeah.
Okay. So if you do a treatment of any type that causes a person to start having some reactions like that, especially TKM, that means that they're toxin overloaded. And you don't send them to the hospital, even though they might survive that, might even get better there.
Mm-hmm.
They could also die. In 2004, Gary Null, Carolyn Dean, and some other doctors published an article in the Journal of Orthomolecular Medicine that showed that every year in the United States, there were 783,000 deaths caused by hospitals and doctors in hospitals. 783,000. So that was the leading cause of death that year.
When I say they go to the doctors, not on our advice, that they don't have the patience to let.
So what you want to do is before you do any treatment that might release toxins, you want to make sure you have on hand liposomal glutathione in the little foil packets from Livon, Livon. You want to have on hand some Nutrimedix berberipinella. Mm-hmm. If the person's vomiting, you don't put the berberipinella in water and drink it like you usually would, but you rub it on the belly and then give them a tablespoon of water to hold in the mouth and sip on every 5 minutes. And usually with a combination of berberipinella, sipping on the water, and the liposomal glutathione rubbed on the lower legs, you can turn around a patient that looks like they're heading to the hospital in usually less than an hour.
Wow. Okay. Fantastic. I want to make sure I pass this on to our medical team so they have that on staff. And also everyone listening, when this begins to make sense for you, make sure you have these basic things on hand.
Yeah, I think everybody that cares about their health should have a bottle of berberipinella on hand and a box of the Livon liposomal glutathione packets on hand.
Okay.
Now, typically on the packets, I do a third of the packet rubbed on the lower legs and then wait about 15 minutes and then put another third on and rub that in, and then wait another 15 minutes and put the remaining third on and rub that in. And usually 3 doses of the liposomal glutathione done that way will start turning around a patient that's having a severe Herxheimer reaction.
What's a good company?
Livon, Livon. Livon.
Okay, good. Yeah. You mentioned that. Okay, perfect.
Okay. Now, I want to say a little bit about a couple of peptides. This is probably one of the more effective ones for mitochondria. Peptides are little short chains of amino acids that are found. Most of them are found in the body. Some of them are synthesized and made available in injectable vials. But most of them are injectable. Subcutaneous injections, and you can do that at home. It's not a big deal if you've had diabetes and had to inject insulin under the skin. That it's similar to that. You use a very fine needle, not a big needle, and a little skinny needle, and just put it into the dermal tissue. Okay, but this particular peptide was developed for Barr syndrome and approved just last year for that condition, and that's a rare mitochondrial disease. But it doesn't work just for Barr syndrome. It works for any kind of mitochondrial disease. So you can acquire that for not a lot of money and do 40 plus milligram sub-Q injection once a day, and oftentimes that'll help the mitochondria quite a bit. It selectively binds the cardiolipin in the inner mitochondrial membrane, stabilizing the mitochondrial structure. It improves electron transport chain function, has the ability to reduce mitochondrial fragmentation and neuromuscular, and supports neuromuscular function and decreases apoptosis or programmed cell death. So a lot of functions. ALS animal studies have shown that it improves mitochondrial health and delays neurodegeneration if it's an ALS animal model, and improves motor function. But has good safety and tolerability. Some subgroups appear to benefit more from it than other subgroups. So the more severely ill you are with mitochondrial illness, the more you benefit from it. There's a variety of other peptides that are beneficial also for mitochondria, directly or indirectly. The humanin is the one I would pick out of the rest of those there. And after that, after you've done a few bottles to the humanin, then graduate up to the MOTS-C. MOTS-C is stronger and more likely to have some Herxheimer-type reactions with it than with the humanin. Cerebral lysin, BPC 157, thymosin beta 4, KPV, LL37, and dihexa are others that can be beneficial. But work with a doctor who has knowledge in peptides rather than just trying to do all this on your own. Okay, gut flora and melatonin. The gut flora produces 100 to 1,000 times more melatonin than the pineal gland in your brain. Now, that's assuming that you have healthy gut flora. If you have very unhealthy gut flora, maybe you don't produce hardly any melatonin. Melatonin is also produced in every mitochondria in your body, but if you don't have enough of the right building blocks to produce melatonin in your mitochondria, then they won't produce melatonin and you won't get the free radical quenching reaction of melatonin in your mitochondria. You can take 5-hydroxytryptophan, which is about 70% absorbed, to get enough 5-HTP inside the mitochondria to produce melatonin inside your mitochondria. If you take melatonin powder or melatonin powder in a capsule, you only have about 3% absorption. So if you're going to do melatonin itself, then you want to do liposomal melatonin. But anyway, melatonin requires the S-adenosylmethionine, which we talked about earlier in that the methylation pathway graphic with the SAMe in the top right corner in yellow. That same substance is necessary to methylate the 5-hydroxytryptophan. I didn't mention that a while ago, but that's really important. Okay. The dose for the 5-HTP that works for most people pretty well is 50 milligrams twice a day. If you start feeling kind of yucky after you take that dose, then you want to get a quinolinic acid test to make sure that that's not increasing, because a small percentage of the population have a defect in the enzyme that results in too much quinolinic acid being formed from the 5-HTP. Okay, but anyway, you can also use liposomal melatonin. There's 6 mechanisms whereby melatonin improves your mitochondrial function. I'm going to put them up there, but I'm not going to read them all.
No, yeah, people can read those.
People can read those later, but that all came out of that article that's at the top, right under the title. Okay, so another mitochondrial test is really important to know about this test, but you have to find a doctor who's hooked up with the AONM organization in UK, because the doctor that runs the lab in Germany, MMD lab, will not do an interpretation. Okay, so you have to get a doctor that's knowledgeable about interpreting the test to work with your doctor here in the United States to be able to interpret the test. It's fairly intricate. Anyway, a good starting place on that test is the M3 blood panel, which is $382. So it's a lot less than the Mitome test. But anyway, there's more than 7,000 peer-reviewed references in the literature about that since they started using that test in 2006.
Wow.
Okay, so there's plenty of data proving that it's a valuable test. I'm not going to go through all the rest of this. The test that I would usually do probably would be the very bottom one there, the M3, M4, and M8, and that one's $570 right now. Make sure that you get enough sunlight every day, because the sunlight has in it red and infrared, and that will help your mitochondria to produce more melatonin and more ATP. So it's a twofer. The LED lights that most people are using nowadays that look like they're white are not white. They're blue-green plus orange to give you a white type of appearance. And because of that, there's no red or infrared in it. And so that's thought to be the next equivalent to cigarettes as far as health damaging effects. Now, fortunately, OttLight has a full spectrum of lights in their LEDs, and they're not terribly expensive. and very worthwhile to get you some OT lights, or some old-fashioned incandescents have broader spectrum than the LEDs, the regular LEDs. And also wear blue blocker glasses from sundown until you go to bed. Okay, and there's also a reference for a night light. If you want to do some reading after sun goes down, you can use a red light to read with. Okay, I'm going to put this up so that people can take a picture of that with their phone when they're going back through it, or pause it there, and then I want them to look at this slide too. Okay, but that kind of is a summary of everything in the part 1 of this presentation, as well as today's part 2.
Putting it all together.
Putting it all together.
This is wonderful. Wow.
Okay, it's a wrap.
It's a wrap. Dr. Cowden, thank you so very much. I'm very excited about this second part. Somehow this made a lot more sense because you gave us so much context in part 1. So I think my whole team is fully prepared to really study these last 2 productions that you put together for us, these last 2 presentations, and really dig deep and start practicing with some of those tests. I want to encourage everyone, when you think about what insurance costs you, when you think about what your prescriptions cost you, your antidepressants, your anti-anxiety, all these crazy meds that we take for all these crazy things, I would invite you to learn doctor's practice. We can practice, and these tests are accessible to you. You can go online and order all these different things. And so how about we all make a hobby out of healing ourselves?
Well, yeah, this is important to think about. A lot of insurance has a copay, and the copay can be 10% or 20%. But years ago, I had a patient with advanced cancer, stage 4 cancer, and she could not tolerate chemotherapy. She could not tolerate surgery. She had an anaphylactic shock reaction on the operating table previously. She could not tolerate radiation therapy. And so she was left with integrative therapy to treat the cancer. And so she said, "How much do you think it'll cost to treat this cancer integratively?" I said, between $25,000 and $30,000, I think, based on past experience. She said, "That's a lot of money." I said, "Yeah, why don't you go ask your oncologist how much he would charge if he was going to do all the treatments that he would do if you were able to do all those treatments." And she asked him, and he said it was $500,000. So her copay for that, for her insurance that she had, would have been $100,000. So she ended up paying me $25,000 and got completely free of all the cancer without surgery, radiation, or chemotherapy at 1/4 what her out-of-pocket would have been if she'd have gone with her insurance. And she's
There
still
you go.
alive.
Yeah, there you go. And again, you can scale all this according to what you can do, when you can do it, how you can do it, but at least you could kind of become an agent of healing and learning and education.
Yeah. Some people don't have the appropriate priorities in their life, I don't think. They spend way too much money on doodahs and gadgets and not enough money on their health.
Yeah. It's changing. I think a new generation is rising. I love you, Dr. Cowden. Thank you from the bottom of my heart.
We hope listening to this episode has brought you closer to experiencing the freedom of wholeness and healing. If you have questions or comments about today's episode, or for updates about R.E.S.T, please visit our Instagram or Facebook at The Place of R.E.S.T. If you would like more information about Virginia, or to support and join the cause of R.E.S.T, please go to theplaceofrest.com/donate or call 949-289-5935. Thank you for listening to R.E.S.T with Virginia Dixon. We'll see you next week.